Hello friends, welcome back to my channel MakeEasyCode. Here DSA made simple. Friends, suppose we have two vertical lines on a graph, and if we pick any two of them, they can hold water between them. The question is, which two lines will hold most water? Let's solve these questions in the smartest way possible. Today we are solving LeetCode problem number 11, that is contained with most water. And the statement is, given array height where height I represent the height of the vertical lines on x-axis. Your task is to choose two indices, that is I and j, so that the area of water between them is maximized. And the formula is given, area equal to mean of height I comma height j into j minus I. So this is not a random LeetCode problem. It have been asked in big tech interviews like Microsoft, Amazon, Apple, and even Google. So learning this trick can give you an edge in real interviews. Let's log the idea with simple examples. Here simple examples as given: height of 1, 8, 6, 2, 5, 4, 8, 3, 7, and the output as given max equal to 49. Because best area in between index 1 and 7, okay, it is 7. So we got the maximum area is equal to 49. Here width become 8 minus 1, that is index 8 minus 1, that is 7, and height equal to minimum of height become minimum of 8 and 7, that is 7 again, and so area becomes 7 into 7, that is 49. Okay, now start with most straightforward approach, that is brute force idea. So here idea is check every possible pair of lines, and the point I have mentioned for this below pseudocode is we have to pick a left node of I for 0 to n minus I, and for each I pair it with every right index, that is j greater than 1, and compute the area. And after that we have to keep track of the max area seen. Okay, so here the time complexity will be big of n square, and space complexity will be big of 1, because you have to test all pair here. Okay, and the space will be constant, as you know, extra space. This brute force idea is simple and correct, yes, but slow for the large input. Now we will optimize this problem with two pointer approach. Okay, so let's dive into the optimized two pointer approach. Here's the code in Python. Don't worry, we will go through each step by step. So first we start by placing left index at index 0 and right pointer at the last index of the list. The variable max area will store the best answer we found. Okay, here we run a loop while left pointer is less than right pointer. Inside the loop, we first calculate width, the distance between two pointer, height, the smaller height between these two lines. Okay, you can say these two lines. Area, that is width into height. Okay, then we check if this area is larger than max area. Okay, we found or update our maximum here. Hope you clear up to this. Now here is the trick. We always move the pointer that pointing to the smaller line inward. Okay, why? Because moving the larger one won't help here. The smaller height is the bottleneck for the area. Okay, so if height of left is less than height of right, we have to move left pointer forward. Otherwise, we have to move right pointer backward. Okay, when the two pointer meet, it means we have checked all possible widest containers and our max area will have the largest area found. Okay. In terms of performance, our two pointer approach is super efficient since we have only move one pointer at a time, and each pointer can move at most 9 steps. So our time complexity is big of n. And because we are using only a few extra variable for tracking kind of position and area, so our space complexity will be constant, that is big of 1. Okay, now let's run the code with an actual example to see how it works step by step. Here the direct example is given, height of 186,254,837, and I have drawn the graph for the respective heights. This is the indexes and this is the values. Now we'll explain this example step by step. Now in the first step, the left index is 0 and right index is 8. You can see in the graph, and values are 1 and 7, and width become 8 as 8 minus 0, that is 8. And we have the minimum height is 1, and we have to compare each time with these two column for the minimum height. Okay, so area become 8 into 1, that is 8. So this is our new height. Okay, now this pointer will move forward by 1, that is, because left height is less than right height. You can see left height is less than right height, so this arrow will move to plus 1. This is the index 1. Now at step 2, our left index at 1 and right index at 8, and values are 8 and 7, and width becomes 7. This is 8 minus 1, 7, and our minimum height is 7. Okay, so our new area becomes 7 into 7, that is 49. Okay, hope you understand up to this. Now this arrow will be go to backward, minus 1. Okay, why? Because now this time the right height is less than left height. Okay, so in the next step, our left index will be at index 1 and right index it will be at index 7, and values are 8 and 3, and width will be 6, that is 7 minus 1, and minimum height between these two columns, that is 3. So our area will be 18. Okay, so in our area there will be no change because we have already the maximum area. Okay, so but this time again this arrow will be come to 6 and minus 1. You can see here, that is right height is less than left height. Okay, so in the first step, again the left index will be the same position, that is 1, but the right index will be at the 6th position, and values will be 8 and 8. You can see here 8 and 8. Now the width will be 5, that is 6 minus 1, and minimum height will be 8 because both are same. So our new height will be 40, but maximum height still will be 49. Okay, so again it will be moved by minus 1, that is this time it will be at 5. Okay, so in the next step, left index will be in the same position, that is 1, but the right index will become to 5 at index 5, and values will be 8 and 7, and width will be this time 4 because 5 minus 1, that is 4, and the minimum height is 4. Okay, we can see here. So a new area will be 16, 4 into 16. So in the maximum area there will be no change, but again this arrow, this arrow, this time it is 5, but again it will move to 4 as we have right index is less than left index. Okay, in the next step, the left index at 1 and the right index at 4 this time, and values will be 8 and 5, but width will be 3, 4 minus 1, and minimum height will be this time, that is 5. So 3 into 5, so area will become 15 now. So again there will be no change at max area. Okay, I hope you clear. And again this pointer, in the 6th step you can see our pointer it is at 4, right? So now this time it will be at pointer 3, and our indexes will be 1 and 3, and values will be 8 and 2, and width it will become 3 minus 1, that is 2, and minimum height here is 2. So 2 into 2, our new area will be 4. So max will be same, there will be no change. Again, the pointer will be moved to at index 2, okay, this time. So at, I can say at the last step, you can see at the left index at 1 and the right index at 2, okay, and values are 8 and 6 this time. Output is 1, 2 minus 1 is 1, and the minimum height is between 2 column, that is 6, 1 into 6, that is 6. So area becomes 6, but our maximum area till this time, till this point, it will be it is 49, okay. So there will no change at area. So again, this arrow, I mean this arrow, it is now at 2 position, it will go to at 1 position, okay. So I mean this time the pointer will be, both pointer will be the same, okay, and the, and our maximum area, it is 49, okay. And that's how, like by smartly moving the smaller pointer, we maximize the area without checking every pair, okay. I hope this dry run make you clear, and now we'll see this code into the LeetCode and check for the submission. I've opened the problem container with most water, that is problem number 11. In the code editor, I'll paste our Python code, and I will click on run. Oh, okay. So here the all sample test cases have been passed successfully. Now I will click on the submit to run it against all the hidden test cases. Yeah, and there you go. We got the green check mark, meaning our solution is both fast and memory efficient. Yeah, and that's how we solve the container with most water problem on LeetCode. All right, let's quickly recap what we have learned today. We started with the brute force approach with checking all pair, which takes big O n square. Then we optimize the solution with two pointer technique, using one pointer from a start and one pointer from end. To solve it take big O n time. We also did a step-by-step dry run to visualize how the logic works. The key trick was to always move the pointer at the shorter line inward. At the end, our solution passed all LeetCode test cases and handled the biggest input. Okay, and the very important thing is, like, if this video helped you, so please like the video and subscribe to my channel, that is Make Easy Code for easier DSA videos. Our next video will be trapping rainwater. That's all for today. Thank you for watching. See you in the next video.